Let A be a 6 cross 6 complex matrix with a cube not equals to 0 and a to the power 4 is equals to 0, then the number of Jordan blocks of A is. So first of all, like we have A being 6 cross 6 complex matrix and a to the power 4 is 0 and a cube is, but a cube is not equals to 0. So first of all, we call this matrix nilpotent matrix because if we take like a to the power of k is 0, so we call a matrix A is nilpotent if a to the power k is 0 for some positive integer k. So here like we are having a to the power 4 is equals to 0. So that means A is nilpotent, and by nilpotent we mean so only eigenvalue is nothing but 0. So its Jordan canonical form consists only of Jordan blocks with eigenvalue 0. So now we also have a cube is not equals to 0. So that means the smallest integer k such that a to the power k is equals to 0, we call it as index of nilpotency. So that means in our case, like index of this nilpotency index is nothing but 4. So that means the largest Jordan block size will be 4. So the largest Jordan block has size 4, then Jm whole to the power of m is 0, but Jm whole to the power m minus 1 is not equals to 0. So if we consider like Jordan block sizes as k1 plus k2 plus k3 plus k4 plus k5 plus or like if I consider the Jordan blocks as some ki, so we have the sum of those to 6, and we know that each ki is less than or equal to 4 for all I, and at least one ki is equals to 4, and they must add up to 6. So that means this is possible like if one split is 4 plus 2 and the other split is 4 plus 1 plus 1, which is 6. So that means the number of Jordan blocks must be 2 or 3. Jordan blocks must be 2 or 3. Therefore option B is the correct answer.